This is talking about halogens. Halogens are in group 7. And then they are all non-metals. It's highlighted there. They are in group 7. So you have fluorine, chlorine, bromine, iodine, and astatine. They will form diatomic covalent molecules because we know that they have 7 valence electrons. Let's say fluorine. So in order to be stable, they will have another fluorine atom come along. So they form Cl2 in this manner, covalent molecule. So fluorine, bromine, iodine, astatine will also behave in the same way. They are always diatomic covalent molecules. If they were to if they were to form ions, what happens is they will accept one electron from another atom. So it forms a negative ion in this way. When they form ions, their ions are generally known as halide ions. You have fluoride, bromide, iodide. This is the naming. For halogens, we come to the physical properties again. So halogens have low melting and boiling point. So it's a simple covalent molecule. So they have low melting and boiling point. This chapter can be related to, connected to your bonding chapter. They will ask you explain why chlorine has a low melting and boiling point. Any idea?
More energy is needed to overcome the strong electrostatic forces of attraction.
First thing is, just now I mentioned it's halogens. Halogens are diatomic covalent molecules. Simple
overcome the strong intermolecular forces of
simple covalent molecules. What kind of intermolecular forces of attraction do they have? Are these intermolecular forces strong or weak?
weak.
Okay, so it's weak. So now we have chlorine, chlorine, chlorine. So like that. All right, so these are your intermolecular forces of attraction. Intermolecular forces of attraction. So we have to say that this, you said it, it's weak. So in order to overcome the weak intermolecular forces of attraction, to melt chlorine or to boil chlorine, a small amount of energy is required to overcome this weak intermolecular forces of attraction. So therefore, the melting and boiling point of chlorine is low. You have to say simple covalent molecules. They have weak intermolecular forces of attraction in between molecules. Third, less energy or low amount of energy is required to overcome this weak intermolecular forces of attraction. Therefore, chlorine has a low melting and boiling point. That's why first line you say all halogens have low melting and boiling point. But you compare according to the group, right? You compare these two. You will observe that the melting and boiling point increase. So they say melting and boiling point of halogens increase going down the group. Then they'll tell you why. Because the molecules become bigger. When molecules become bigger, the intermolecular forces of attraction become stronger. So more energy is required to overcome these forces, so the melting and boiling point will increase. It's because the melting and boiling point increase, then you find that chlorine is a gas at room temperature, Bromine is a liquid at room temperature. Then iodine is solid at room temperature. Okay, so they can ask you why do halogens have low melting and boiling point? You will write down the explanation I gave you just now, just about this. Then the second kind of question they can ask is, please explain why the melting and boiling point of halogens increases down the group. Then you give them this answer. Okay, so that's because that's related to melting boiling. Then second physical property, right, is about their appearance. So the appearance, right, the color will change from lighter to darker. Like you have the images down here, chlorine is yellowish green. I think that's from, okay, chlorine is supposed to be yellowish green. Then fluorine is yellow, pale yellow, then etc. So down here, the color and physical state shown to you already. Physical state at room temperature. So fluorine is a pale yellow gas. Then chlorine is a green gas at room temperature, greenish yellow. Then bromine is dark red liquid, and iodine is dark gray solid. See this one. Then astatine is a black solid. But if you have to vaporize them and all of them are gases, then fluorine will be pale yellow, chlorine will be greenish yellow or green, then bromine is brown gas, iodine is purple gas, and then astatine will be black. We seldom see textbook ask about talk about astatine. The focus is actually on the first four. Focus on the syllabus is on the first four. But what happens is they can give you information on the first four, and then they ask you to predict the properties of astatine or predict the appearances or other properties or chemical properties of astatine. Astatine wise, they usually is a prediction question. So this is a summary. They are non-conductors of electricity. Halogens are non-conductors of electricity. You should know why. What is the reason? Can you tell me what is the reason behind why halogens are non-conductors of electricity?
Because they are not metals.
Because they are not metals, that's one. Any more? It is actually because they
because they are transition metals.
No, they are not transition metals. Halogens are non-metals. So they are not metals, then their electrons are not mobile, so they cannot conduct electricity. Then that's one, because they are not metals. Then another thing is because they exist as simple molecules. So they are not ions. So they will not carry charge. They cannot conduct electricity. So it's number one, when they explain why they are non-conductors of electricity, you have to say they are non-metals. So no mobile ions, no mobile electrons. So number two, you say that they are not ionic substances. So when they are not ionic substances, they have no mobile ions to conduct electricity. Okay. So on going down the group, the color intensity increase because like this, change from lighter to darker. Then the melting point also increase. That I show you already, the melting boiling point increase here. So we start formally from here. The ones earlier are physical properties. So chemical properties, they already say it's chemical. That means they are talking about chemical reactions. Chemical reactions depend on their valence electrons. This is what we know from earlier. When we did alkali metals, it's also like that. Okay, so they have similar chemical properties because they have similar electronic structures. So over here, you see the electronic structures. And you see the electronic structures over here. So this one is 27. So the valence number, valence shell has 7 electrons. Chlorine is 287. So valence shell is also 7 electrons. Then bromine is like this. It has also 7 valence electrons. So because of this, halogens will have similar chemical properties. So if one fine day, if you see a question, they say, please explain why halogens have similar chemical properties. Then you should say that, or they say, please explain why fluorine and bromine have similar chemical properties. So what you would do is you would give them the electronic structure. Okay. Then after that, you say that because fluorine is 27 and bromine is 2887, so they both have 7 electrons in the valence shell. Then since chemical properties depends on the number of valence electrons, then fluorine and bromine has similar chemical properties. So you write the answer something in this manner. Okay?
Yeah.
Okay. So then we go into the reaction proper down here. So chemical properties, then chemical reaction. So number 1, they react with metals to form salts. So you have iron here. Iron reacts with chlorine to form iron chloride. This is iron 3 chloride. So this is number 1. Number 2, they react with non-metals to form covalent compounds. So hydrogen is non-metal. It reacts with chlorine, you get hydrogen chloride. And hydrogen chloride, if dissolved in water, it will become hydrochloric acid.
Hydrochloric acid.
When it dissolves in water. Number 2. Number 3 reaction, you see a star here. That means you don't need it for your next your Sec 4 exam, but you will need it if in the future you want to continue your Sec 5. So halogens are this thing called powerful, they are called oxidizing agents because they gain electrons readily. But I'm not gonna continue talking about this. Okay, then you have this one that you need to know. Just the reactivity of halogens decrease on going down the group. So earlier on we have that you have fluorine, chlorine, bromine, iodine. So this means that fluorine is the most reactive and iodine is the least reactive. Okay, that is statement number 3 is talking about that. So fluorine more reactive, most reactive, and the one at the end, the last element in group 7 is the least reactive. So this is another question that they would ask. They asked you, why is fluorine the most reactive? Or they ask you to explain why reactivity decreases down the group. So the main purpose how they react is because they gain electron. Do you remember that? How group 7 elements form an ion is by gaining an electron. Do you remember that? Means gain electron easily means that the more reactive. If it is difficult to gain electron, means it's less reactive. Are we together right now? So you will examine this tree. Then you think about whether which one will gain electrons more easily. So what happens is fluorines only have 2 shells. So that means the atom is smaller. So it is easier for the nucleus of fluorine to attract an electron. You agree with that? So it's easier for fluorine to get an electron. So bromine, on the other hand, it has 4 shells. So bromine is the bigger atom. So it will, because of its size, because it's bigger, then it's more difficult for bromine, the nucleus of bromine or bromine's nucleus, to attract an electron. So because of the difference in the ease of attracting an electron, so you can see that fluorine is more reactive and bromine is less reactive. You okay with that? Can? Okay, so that is the simplified explanation that you can use, because the explanation here is relatively more technical. And electron shielding, I do not think you are required to know. But electron shielding just simply means it's bigger or smaller. The electrons get interfered by, the attraction of electrons are interfered by the atom size. But you are not required to know that term, so you will stick to whatever I said earlier. Because just compare size. Then after that you say the fluorine is smaller, easier, because it's smaller, it's easier to attract electrons. Then bromine is bigger, so it's more difficult for it to attract an electron. So fluorine is more reactive than bromine. You will use that. Okay? Can? Then there's this magical reaction called displacement reaction. What does displacement mean in English? Displacement in English and displacement in physics and displacement in chemistry means 3 things. They are kind of different. Same, but different. So what is the English meaning of displacement? Can I assume, okay, can I understand it in such a way that let's say I displace something, that means I make something move out of its original position. Can I understand it that way in English? So in chemistry, halogens and metals, right? Displacement can also be understood in the same way. So the displacement reaction will cause something or an element to be moved out of its original position. by another thing. So in drawings, it simply just means you have A and B, okay? Then you have a C come along. Then because of C, then C can take the place of B, and B gets kicked out, like gets displaced. You understand the drawing?
Yeah.
Yeah, so C comes to AB, then C pushes B out, so C displaces B, and then B gets kicked out of where it is, and then it's sitting alone like that. So we say B has been displaced. Right. So this sentence, right? This drawing means B has been displaced by C. Acceptable? Agreeable?
Yeah.
Okay.
Mhm.
So now our situation is like this. We look at my second line. My second statement say a more reactive halogen will displace a less reactive halogen from its halide. So the example is below. We have chlorine added to sodium bromide solution. So in this case, if we were to compare the question to whatever I mentioned earlier, so chlorine has been added to sodium bromide. So what would you expect? So chlorine, based on earlier slides,
Chlorine being more reactive than bromine, it will displace bromine.
yes.
Then it
So
becomes an NaCl. Then bromine becomes a yolk.
yeah, so then but it's chemical bonding. So bromine cannot sit alone. It will react with another bromine to become bromine molecule. So this will be like that also. Okay. So in the start the gist of this whole thing is more reactive displays less reactive halogen. So you'll eventually get something like that. Okay. So they would ask you to do chemical equations. They would ask you to write ionic equations. So if you are fine, I will skip the writing of chemical equations. Okay. Then another popular question that will come from a displacement reaction of halogen is they love to ask for observations. That means they ask what you can see. What you see. They love to ask observation question because we know that halogens are colored elements, colored compounds. Okay. So in this case, you will see chlorine is a yellowish green gas or greenish yellow gas. Okay. So yellowish green gas get thrown into sodium bromide. Sodium bromide is a colorless solution. So why is it colorless? Because most sodium salts are colorless solution. I will summarize the colors and give another copy to you later. Okay, so sodium bromide is a colorless solution. Then when it gets displaced, bromine turns out. Bromine is a reddish brown solution, right? Right. Yeah. So that means if they ask for observation, you will see that The greenish yellow gas dissolves. Okay. The colorless solution turns reddish brown. If they ask for observation, this is what you write. The greenish yellow gas dissolves and the color solution turns into reddish brown because reddish brown comes from the bromine and sodium chloride is still colorless. So these are the two things they take note of. First, the chemical part of it. Second is the observation question. So then the second case, the second example, we have chlorine to sodium fluoride. So then they would ask you predict the outcome of this reaction. Then you have to identify whether chlorine is more reactive than fluorine. Okay, so is chlorine more reactive than fluorine?
No, because chlorine is below fluorine.
Right, that's right. So in that case, then we can say that no reaction happens. And then if it's observation, then it's no visible change. So these are the two things to write if they ask that kind of question. So this is a summary. So equations are given to you as well. So the ones with dashes means this is bromine with bromide and then iodine with iodide. So all this, there's no reaction. Bromine with chloride. Here, right? Bromine is less reactive than chlorine. That's why there's no reaction there. And iodine with chloride and iodine with bromide will have no reaction because iodine is lower than chlorine and bromine. So the reaction will be only these three. So you have chlorine and potassium bromide means chlorine will displace bromine. So this reddish brown substance is the bromine liquid. Then with potassium iodide, brown solution is formed and this brown solution is iodine. Okay, so same goes for this one. This one, you see a star, not tested. Bye-bye. So this is the summary of the trend. So you have physical state, color, melting boiling point, and reactivity. So you can take this down, or you can copy down this slide, or you can print this slide, or you can bookmark this slide so that you can use it for revision. Question 4. Chlorine is in the group 7 of the periodic table. It is expected to have a chemical property similar to yes, because they are in the same group, they have similar chemical properties. Which of the following statement about the halogen is correct? An element with a higher atomic number can displace the element with a lower atomic number. What does this sentence mean? What is the true meaning behind this sentence? Higher atomic number. Higher atomic number, what does it imply about the size of the atom?
Means bigger.
Okay, so let's reread the question again. So an element with an element with a smaller, okay, with a bigger atom can displace the element with a smaller atom. What does this mean? If you were to a bigger atom, right? This is halogen. So name an atom, a halogen that has a bigger atom. Then you name one which has a smaller atom. Bromine is bigger. Okay, so let's put bromine here. Then the smaller one, fluorine. Okay, so now we reread again. Okay, an element such as bromine can displace the element, can be displaced by fluorine. An element such as bromine can displace the element which is smaller, which is fluorine. Will this statement still be correct? Bromine cannot displace fluorine. So that means D is not correct. So we will take this out.
Reactivity decreases down the group.
Yeah, correct. So D is not the thing because you want displacement is more reactive, displace less reactive. Okay, so 3 other options. We go through one by one. A, they are in the same period of the periodic table. Is it correct?
vertical periods are horizontal.
Excellent. So this is, they are in the same group of the periodic table. Okay, so then reactivity decreases down the group. So you mentioned that already. So this is not correct also, right? So C is also out, right?
B is also wrong
Why B is also wrong?
because
Valency
because
is valency is when you form ions, the number that switch around, right? Like that, right? The number that switch around. This
yeah,
number is the valency. So chlorine does have a valency of 1. So your number,
-1.
valency, they don't have the charge. When they say charge, then it's -1, +1. If it's valency, it's just a number.
Yeah.
That's why it's B. It will gain 1 electron to form stable electronic structure, so the valency is 1. Fluorine, chlorine, bromine, iodine are found in the same group of their periodic table. What is the group number in the periodic table? Yep. Fluorine, bromine. Wow, my spelling wrong. So, okay, fluorine, bromine, iodine are found in the same group of the periodic table. State two similarities of these 4 elements. Yes. Then 4 or 2. Sorry, 2. This is just 1. Okay, I think they have more. Okay, this is another 2 they have. So the other 2 other similarities is diatomic because they form diatomic molecules, and then they form ions of -1. But of course, they also have low melting points and they are not non-conductors of electricity. Next, so state 3 differences in properties of these 4 elements down the group. 3 differences. Any more? So you say reactivity is changes gradually. Okay, then color intensity increases down the group. Okay. Bromine gas is allowed to pass through the solutions containing fluoride ions, and iodide ions. Okay, so we will come to this table. Then, okay, let's do this. So this is the ion. So we have fluoride, bromide, iodide. So then you have bromine gas. So bromine gas and fluoride ion, any reaction?
Yeah.
You throw bromine liquid into potassium fluoride, any reaction? Then come back, we think about more reactive displaces less reactive.
Chlorine is more reactive than bromine.
So chlorine is more reactive than bromine. So adding bromine into chloride will not give you a reaction.
Chlorine is more reactive than bromine.
Any reaction? Chlorine is more reactive than bromine, but what you do is you have a bromine gas passed into the fluoride ion. Can displacement happen?
No.
No. So this is on its own, so no reaction here. Then last one, bromine and iodide.
Iodine is less reactive than bromine.
Yes. Any displacement takes place?
Yes.
Yes. Then what is the observation since there is? So iodine will be displaced. So what is the observation? Then if you go to the slides earlier, you will see that bromine in solution form will be a brown solution. So in the end, you will see that the color solution becomes brown. And the reddish brown color bromine disappears. Okay.
Yeah.
Okay. Then they ask for ionic equation with, which is this. I will not go through.